right, question 16 over here is the boiling point and the structure. And they already give you this is the answer. This is the order. The highest is water. The lowest is H2S. Okay, we are supposed to explain the boiling point trends in terms of their structure and bonding. So what are we supposed to write down? So in terms of structure, we need to say that they are all simple molecular structure. Or they can say simple covalent compound. Right? So in terms of bonding, we are talking about boiling points. So because we are talking about boiling points, we are talking about intermolecular forces. So because it's intermolecular forces, so we are looking at like London dispersion force, dipole-dipole, hydrogen bonds. So we have to look at each one to understand whether they are polar or non-polar. Okay, one good thing is they are all the same group. So all the same group, right? Let's use X to represent the one that is changed from sulfur to selenium to thallium and to oxygen. Okay, something like that. So everything is bonded to H and they are lone pairs. So we can see the structure is bent and is likely to be polar because whenever there's a lone pair, the shape is not symmetrical. So the dipoles do not cancel out. So we expect a net dipole in the picture, right, in the structure. And therefore, we expect they are polar. So with them being polar, we expect them to have dipole-dipole plus LDF. Right, that's a general one. Now, out of it, we have one special one that is OFN. I see water, which is H bonded to OFN. So for that one, it will not be dipole-dipole and LDF. It will be hydrogen bond, which is stronger than the rest, right? Which is the strongest intermolecular force. So it somehow explains why H2O is the highest. But we still need to explain what variations between the S, the SE, and the TE. So to explain the variation between the S and the SE and the TE, we will have to go to the periodic table. And we find that actually they are all in the group 16, but is down the group. So you're expecting the size is getting bigger and bigger and bigger and bigger, right? 1 shell, 2 shells to 3 shells to 4 shells. So therefore, that variation between the H2S, H2SE, H2TE is to do with the London dispersion force, which is directly proportional to the size of the electron cloud. So how do we phrase our answer? So we will first phrase that they're simple molecules. Second, we will have to acknowledge that the H2S, H2SE, and the H2TE, they have dipole-dipole and London dispersion force between molecules. So we just recognize what's the intermolecular force first. Whereas H2O will have H2O as hydrogen bonds between molecules. Okay, so we can compare them first. So if you want, then you can talk about hydrogen bond is much stronger than the dipole-dipole and the LDF. So that's why water is the highest. But we still need to explain the difference between that few, which is having the same dipole-dipole and LDF. So then we bring in that H2TE is stronger than H2SE, which is stronger than H2S. As down the group, the size of electron clouds increases. And hence, the London dispersion force increases. All right. So let's explain the difference between the three of them. So the London dispersion force varies with the size of the electron cloud, and that leads to some variation in the boiling points. Okay, that is for question 16.